Okay, here we go, finishing off the last one, so 23 through 41. Okay, so on this number 23 on your paper, it said to solve for k. So we're trying to isolate the k. So we can't get rid of anything underneath the radical yet. We have to get rid of this part first. So technically this is divide by k, so the opposite would be to multiply by k. So when I move it to the other side, I would have kn equals 1, which we don't need to write 1, but the radical is still there. Okay, we haven't done anything like that. Okay, well, this one actually is one of the easier ones because really we almost have k by itself. So this is times, right? So the opposite of that would be to divide. So what I do here, I'm going to do over on the other side now. So you could write it right here, which is the right answer. If some of you wrote it as bt over 2p, still inside the radical, and then you wrote this over n, that would be the same thing. Because really there's a 1 in front of that. Okay? So this is your answer right now. Okay. Which is the same as what's down below. Okay, number 24. Okay, so we're simplifying radicals, but now we've got negatives. So negatives we learned are represented by i's. Okay, so I'm still breaking down 16, but I know that that's going to come out as an I on the outside of the radical. I'm just going to see if it winds up being a perfect square. Okay, well, 16 is a perfect square, which winds up being 4. So there's not going to be anything left underneath there, so it's just a 4 because everything came out. Okay, which is 4 times 4, there's my error, it comes out, there's nothing left. Okay, well, now we're going to do the same thing for 196. Okay, so 196 is a perfect square as well, which is 16. Okay, so it comes out as 16i. 14i. So 196 is 14. So now when I add 14 and 4, I get 18i. Because they're like terms. Okay, we just look at the i's. They're kind of like x's. We would combine them. Okay, next one. This one we have to distribute. The parentheses are not right next to each other, so we don't FOIL. We're just distributing this negative to these and then combining like terms. Okay, so I have 8 minus 5i, and then a negative times negative make it positive 7, and then again a negative times a negative would make it positive 3i. Okay, so we're just combining our like terms. So combining those two would make 15, and then combining those two would make negative 2. Again, can't go any further because one has pi, the other one doesn't. Okay, number 26, bringing out an I, but then breaking this one down, and this one is not a perfect square. And again, you can start with 2 if you wanted to. I am going to, I'm going to start with 2. I'm going to do 2 and 49. Okay, so 49 would be 7. Okay, so I'm going to bring that out along with the I. So the 7 comes out and the I comes out from the negative. But what was still left of the prime numbers is the 2. So that stays on the inside. Okay. Okay, number 27. Okay, so much like radicals, we can't have radicals in the denominator. We also can't have i's or imaginary numbers in the bottom. So when it is by itself, okay, all you have to do is get rid of the I. So I'm going to multiply the top and the bottom by the I. If you have any that are on the bottom, this is not this one, but say you had 2 minus I, when you go to multiply the top and the bottom, you would do the opposite, which would be a 2 plus I on the top and the bottom, but that's not this problem. Okay, so just keep that in mind that if you happen to have that on the final. Okay, so what I'm doing is I'm distributing the I to that one, and then the I to that bottom. So on the bottom, I would have 2i squared, and we learned that I squared is the same as having a negative 1. So now I really have 2 times negative 1, so on the bottom it's going to be a negative 2. Okay, well now on the top, I've got to distribute that. Okay, so that's going to be a negative 9i. And then I times I, we just said, was I squared, and I squared is equivalent to a negative 1. Okay, So you could leave it like this, or you would know that a negative over a negative is the same as having a positive. So you can have that, or you can switch all of these, because again, a negative over a negative is a positive. You can switch all of them if you wanted to, or just leave it like that. So either one of those answers is the proper answer. Okay, so 28 through 34, you were told in class that you have 2 answers. Okay, so multiple ways to do this. One way is easier than the other, but doesn't mean that you won't get the right answer if you go the other route, as long as you know what you're doing. Okay, so on this, you could move the 64 to the other side and set it equal to 0, and then use the quadratic equation. So you would have the A and the C, you just wouldn't have the B, and then you can get your 2 answers. So going through the quadratic equation and plugging it in would be one route. I think it's easier to actually solve this because we don't have as many things to solve where I can solve to get the x by itself. So this is 5 times x squared, so to get rid of that I would divide, and when I do to one side I'm going to do to the other side. Okay, so now I am at this spot. Okay, well I need to get the x by itself, so the opposite of squares, take the square root, but what I do to one side I've got to do to everything on the other side. The square gets rid of the square root, which leaves it as x. 64 is a perfect square, which is 8, but 5 is not, so it's still there. So if you remember, we cannot have radicals in the denominator, so in order to get rid of it, we multiply it by itself. Okay, well on the top, I can't combine those because one's a whole number, one's a radical, so it's going to stay as 8 at 5, but it's a positive and a negative, because if you remember, in the quadratic equation, you have a positive and a negative in that. Okay? And then on the bottom, this would really be square root of 25, which is just, okay, so there's your answer. Okay, so again, make sure you have a plus and a minus on all of those. Okay, number 29, you again can use the quadratic. There's your A, your B, your C, or you can do factoring. And this one you can actually factor down. Okay, so I'm going to do some this way and some with the quadratic equation. So signs are the same, they're both going to be negatives. Okay, so my factors of 9, okay, are 1 and 9 and 3 and 3. If you've heard me over and over when we've done this, it's usually not the 1 and something. Usually it's the other one is where I would start. Okay, so my factors of 9 are going to go in this first spot. So I'm not going to do 1 and 9, I'm going to do 3 and 3. Okay, and I'm going to split up my x's. Okay, and then my factors of 5 go in the second spot. Well, the only factors of 5 are 1 and 5. Okay, so I'm just checking this just to make sure I did it right because I need to get a negative 18. So if I distribute that to check it, that would give me a negative 15x. That gives me a negative 3x, which gives me a negative 18x. So I know I did it right. Okay, but we're solving these quadratic equations. So each one of these are equal to 0. So that means 3x minus 1 is equal to 0, and we solve it. And then 3x minus 5 is equal to 0, and we solve it. So we move that over and divide by 3, move that over and divide by 3. Okay, so my 2 answers on this are 1/3 and 5/3. Okay, same thing on this one. I would prefer to do this over quadratic if I can, if it's quicker, as long as it works. Okay, do I have any factors in 45 that subtract to give me 4? Yes, 9 and 5, right? Okay, so when it ends in a negative, it means the signs are different. So one's a plus, one's a minus. I split up my x's, and then 9 and 5, they're different numbers and different signs. So you always take the larger number and put it behind whatever the sign of your second term is. Okay, so that means the 9 is going to go here and the 5 is going to go here. If you don't trust it, check it. Okay, this times this is a negative 5x. This and this is a positive 9x. That gives you a positive 4x, which is what we were trying to get. So if you had your positive negative switch, then you would have had a negative here and a positive here, which would have given you a negative 4x. So you just need to switch your signs. Okay, but we had it in the right spot. Okay, so now we're setting each one of the parentheses equal to 0. So this is equal to 0, so I move the 9 over, right? And then this is equal to 0, and I move the 5 over. So those are my 2 answers. Okay, now we're going to practice quadratic equation. Okay, so quadratic equation, we need to know what our A, our B, and our C are. Okay, when we plug it into our equation, this is your quadratic equation. And the only reason why I'm saying I'm going to do this because I have 4 in here, I have 6 in here. I could do the 1 and 4 and the 2 and 2, but I also have 1 and 6 and 2 and 3. It just seems like it would take longer than to just use the quadratic equation. Okay, so negative b. So my b is 4. Okay, so I'm going to put in a negative 4. Okay, I'm going to square my b, and we just said b was 4. So 4 times 4 is going to give me 16. And then I have a negative 4 times my a, which is 4, times my c, which is a negative 6. Okay, all of that's going to be over 2 times a. Well, my a was 4, so 2 times 4 is going to give me 8. Okay, so again, I think you know how to do this. I don't need to go through this whole thing. We've got a negative times a negative, so there's going to be a positive here. And then breaking down what's underneath the radical. So the answer to number 31, once you get done, can be reduced because these guys are going to have something in common plus what's going to be up here. Okay, so the final answer on this one, so if you struggled on that one, come see me. Okay, I can actually go through it. I'm just trying to save time on this video for those that are just checking their answers. Okay, 32, same thing. Here's my A, my B, and my C. Okay, so it's negative B, so it's going to be a negative 2, plus or minus B squared, so 2 squared is going to be 4, minus 4 times A times C. So again, I'm going to wind up with a positive underneath here because I have a negative times a negative. Okay. And all of that's over 2 times A. Well, 2 times 4 is going to make it 8. So this one's going to be similar to the last one that you did, where these guys are going to have something that's going to break down. So I'll let you go ahead and break down what's underneath the radical. Okay, and simplify it down. If you don't get this answer, you can come and see me and we'll walk through it and find out what your mistakes were. But the final answer on this one was a negative 1 plus or minus rad 13 over 4. Okay, okay, number 33. We like this one because you're not actually going to solve anything, you're just rewriting the quadratic equation. This is my A, this is my B, this is my C. Okay, so it was negative B. Well, now my B is a G. Okay, then underneath was B squared. Well, it's not a B anymore, now it's a G squared. Okay, the 4 is always part of my equation. And then I used to have an A next, but now the A has become an F. And then we have an H. Okay, and then 2 times A. Okay, so now it's not A, it's 2 times F. Okay, and this is all they were looking for. It's for you to replace the A, B, and C with the new letters that are in front of us. Okay, number 34. Okay, factoring this one down. There are no factors of 18 that add to give us 6. Okay, so that one would have been one that I probably would have tried with just using the 2 parentheses, but it doesn't wind up working because there are no factors of 18 that add to give you 6. So we actually have to use a quadratic equation on this one. So there's my A, here's my B, here's my C. Okay, so it's a negative B, but this already is negative, so I'm going to change it to a positive. Okay, then underneath, I'm going to square a negative 6, which is 36, minus 4 times A times C. And then all of that's over 2 times A, so 2 times 1, which is 2. Okay, so I need to, because we have a negative, we don't have 2 negatives like we did on the other ones. I'm going to go 4 times 1, which is 4. Okay, and now I'm going to go 4 times 18, which gives me 72. So I have a negative 72. So now I have 36 minus 72. Okay, so minus gives me a negative 36 underneath the radical. And then I have 6 plus or minus over 2. Okay, so 36 actually is a perfect square. But the problem is we have this negative. So remember the negative when it comes out is going to change to an I. Okay, so now what I have is 6 plus or minus 6I. Okay, because 36 is perfect, which came out, but I have the I there, over 2. Okay, and then this can simplify because 2 can go into all of those. Okay, so your final answer reduced, if you didn't reduce it, would be this. Okay, you can write it over 1 if you want to, because 2 goes into 2 one time, but you don't need to. Okay, just divide those into there. Okay, finding the discriminant. So the discriminant comes from the quadratic equation, but it's just what is underneath the quadratic equation, which is this part. Okay, you don't actually find the square root. You just plug it into this. Don't take the square root of it. Okay, so here's my A, my B, and my C. Okay, so I'm going to square my B, which is 16. It's negative 4 times negative 4. And then I got 4 times A times C. Okay, so then you would multiply these guys and subtract 16, so you're going to get a negative number, because 4 times 3 is 12, and then 12 times 3 is going to give you a big number. So we've got an 8, which is 13. Okay, we're going to subtract it, and you get a negative 20. So that is your discriminant. Okay, so discriminant is just this part of the equation, not the square root. Okay, quadratic equations. So 36 and 37 are done the same way. Okay, so before I actually walk you through this, where this is coming from is when we had like x plus 2 and then like 2x plus 5, and we got our two answers. We said, okay, well, I'm going to move that over. So one of my answers is negative 2. I'm going to move that over, which is negative 5, but then I've got to divide by 2, so those are my two answers. Okay, so if you notice, when we have the answers, when we plug them back in, it's the opposite sign. Okay? When we plug them back in, it's the opposite sign. Whatever's on the bottom goes in front of there, and then this one goes there. Okay, so what is happening is whatever goes in, it switches to the opposite sign. So for this one in your notes, I had x minus, and then whatever they're saying the answer is, you're going to plug it into there, but you got to switch the sign because of the negative. Okay, so what we have here is x, but I've got to switch these signs. Okay, so now it's a positive 1 and a negative 2i. Okay, well, I'm going to do it again, plugging it back in. So I have an x, but now it's a positive 1 and a positive 2i. Okay, so in this one, they asked for you to actually write the original quadratic equation. Okay, not to factor it, not to solve for it, because they actually already solved for it. They told you that these are the answers to write the quadratic equation. So in order to do that, once you plug it back into those parentheses, you've now got to distribute and combine like terms. Okay, so I've got to go x times x, which is x squared. That times that is going to give me a positive 1x. That times that is going to give me a positive 2xi. And again, it doesn't matter the order of those guys. Just make sure when you go to do it again, you have it in the same order. Okay, so that one's done. So if you remember in the notes, I said when I started to distribute the rest, I grouped them with the other like terms. Okay, you can write them all in a single line if you want to. I just think it's easier to group. Okay, so I've done distributing that x. Now I'm going to distribute that 1 to everything that's on the other side. So there's a 1x. Well, I have another one that's like that, so I'm going to group it with it. Okay, 1 times 1 is 1. I don't have one like that, so I'm going to write it off to the side. Okay, now I go 1 times 2i is just going to be 2i. If you notice in red, I don't have one that just has I, so I'm going to write it off to the side. So it's going to be 2i. Okay, so now I'm done with that. So now I'm going to distribute this guy. Okay, well, I have one that has x and I. Okay, so I'm going to group it with it. So that's a negative 2xi. And I just made sure I wrote it in the same order. Okay, now I'm going to change this one to this one. So it's a negative 2i. And I have another one that's 2i. So I'm going to group it with that. Okay, and then my last one is a negative 2 times 2, which is a negative 4. But I times I is I squared. And we learned something about I squared. I squared is the same as having a negative 1, so it's going to change that negative 4 to a positive 4. So now I have another one to group with. Okay, so this guy's gone because I just rewrote it. Okay, now we're going to combine all our like terms. X squared, I didn't have another one. 1x, that's going to give me 2x. These guys cancel each other out. These guys cancel each other out. So the only thing I have left are the 4 and the 1, so that gives me 5. Make sure you set it equal to 0, because the question said to write it as an equation, and equations have equal signs, so you have to put the 0 in. Okay, so that is your answer for 36. Okay, 37 a little bit easier. Doesn't have i's in it. Okay, but again, we're doing the same thing. We write it in with the x, but I switch the signs to the positive one. Okay, remember this one goes in front of the x, but I'm going to switch this to the opposite side. Okay, now we're distributing. So 6x squared. That gives me a 5x. That gives me 6x. So 6x and 5x give me 11x. And then that gives me 5. And again, I'm done as long as I have 8 equals 0. Okay, so that's going to be your answer. Okay, 38. Didn't give myself enough room for this. Okay, so I need to factor this down. Okay, it's perfect squared binomial. Okay, so when we're solving for x, because we want it to look like this, like the quadratic equation, there's no fractions. So we got to get rid of the fractions. So to get rid of fractions, you learned way back in algebra that you can multiply by the common denominator. Well, this has x's. So what we do when we write it on the outside is just make sure that we have one of each of one of the denominators, okay? So I put parentheses around the whole thing, and I write each of the denominators on the outside. You don't write these guys twice. You only need them once, okay? So I have an x plus 5, and I have an x minus 5, okay? And those are the only denominators that we have. Okay, so what we're going to do, and I'm doing this in different colors, just know that after I do it, those colors need to disappear. I just can't undo it, okay? So what we're doing is we're cross-canceling. So I would show you with my hands and say, well, I could cover up the x plus 5 and the x minus 5, okay? So if I did that, it just looks like this. These guys would cross-cancel with these guys, and it just leaves what's at top, which is 10, okay? But again, like I said, that mark I just made needs to disappear, because now I got to do it again. Okay, so I'm just going to use a different color. So on this one, the x minus 5 would cross cancel with x minus 5, but this is still there. Okay, so that would mean that I need to distribute that with that negative 1. So when I distribute a negative 1 to it, it's going to become a negative x and a negative 5 now. Okay? All right, now again, okay, what's on the outside, that's still there, the x plus 5, the x minus 5. There is no denominator here for me to cross cancel, so that means that both of these guys are still there and needs to be distributed to that. Okay, so really that's an x plus 5 and an x minus 5 that is still there. Okay, so when we distribute it, it's going to take us back to that original, which was that x squared minus 25, which is this guy right there. Okay, now I got rid of my fractions. So now I just need to make it look like this guy, where everything is on one side, so it's equal to 0. Okay? So if I combine those two, this would be 5 minus x, right? But I need to move it to the other side. So when I move the 5 to the other side, it becomes a negative 5. And when I move the negative x to the other side, it becomes a positive x. Okay? So I have a positive x, and then combine those two, which would be negative 3. And there is my answer. I just moved everything to the other side. Okay, this next one's the same thing. Okay, I need to get rid of my denominator. So I write one of each on the outside. So I have a p minus 5, a p minus 3, and a p. This time I'm not going to cross off like I did before. Okay, so I'm just going to point to them. Okay, so I have a p minus 5 and a p minus 5. So that means that these two are still there. Okay. So if I were to put those two together, that's really p squared minus 3p. That gets distributed to my numerator. Okay, so that's going to make it 2p squared minus 6p. Okay, now I'm going to do it again. Okay, the p minus 3 would cross off the p minus 3, but that means that these two are still there. So if I put those two together, that would be p squared minus 5p. That needs to get distributed to 1, which is the numerator, right? Which is not going to change anything. So it's going to stay the same. Because 1 times all of that is going to keep it the same. Okay, last one. P would cross cancel with P, so that means that these two guys are still there. And I need to put them together. Okay, so P minus 5 and a P minus 3. So if I distribute it and put those together, that's going to be P squared. Negative 5p and a negative 3p is going to be a negative 8p, and then a negative 5, negative 3 gives you a positive 18. Okay, those two combine, and then these two, 8, 9, 10, 11, 12, 13. Okay, if I move the p squareds to the other side, doesn't matter which one I move, the left or the right, they're going to cancel each other out. Okay. Now I just have p's to solve for. So I'm going to move this guy over to this side and change it to a positive 13p, which makes 7 7p, and then I still have that 15 over here. So my last step is divide by 7, divide by 7, so there's your answer. Almost there. Okay, number 40. Last two are graphing. Okay, so in order to graph when it's in quadratic formula, is you're going to use that negative b over 2a to get your x. Okay, this gives you your x coordinate. Once you know your x coordinate, then you can plug it back into where the x's are at to get your y coordinate. Okay, this gives you your vertex of your parabola that we're going to graph. Okay, so right now, this is my a, this is my b. Okay, so my b is 1, so it's going to be a negative 1. Okay, then 2 times a, well, my a is a negative 3, which gives me a negative 6. Okay, well, a negative or negative is same as having a positive. Okay, so I have 1, 6. That's my x. Okay, so what I'm going to do now is plug it back into my original equation everywhere there's an x. Okay, so solve for my y. So I have a negative 3. Okay, I have an x now. I'm going to put 1, 6 there. I need to square it. And then I have an x. I'm going to put 1, 6 there. Okay, so in your calculator, I'm going to write these down and I'm going to do it so you can try it and make sure that you've got it. The first order of operations is to do the exponents. So you're going 1 divided by 6, which gives you 0.1666666. It goes off your calculator that you're going to square. So you're going to hit the square button or times it by the answer, times it by itself, okay, which should give you 0.0277778, okay, that you're now going to multiply times a negative 3. Which should give you a negative 0.083333, okay? So then that answer, and it's negative, that you're going to add to 1, 6, or 1 divided by 6, you should get now a positive 0.833333. So it's positive that you're going to add a positive 2 to, which now gives us 2.083333. But we don't need to keep on going. Okay, so this is your vertex. So when I go to graph it, remember these don't need to be exact. Okay, it's not a 1/4, it's like super tiny. So it's just like barely beyond the y-axis. Okay. Okay, and then I'm going to go up 2. So up 1, 2, and again, this is a guesstimate. Okay. But then you need to know, is it upright or downright U? So when you go back to your graph, it's a negative, so that means it's going to be down. Okay. So all you just need to do is make a downright U going through that. That's it. Okay, 1 point. So this is what we're looking for, the actual graph of what it looks like. Okay, last one, 41. Okay, so the only difference on this one, you're doing the exact same thing, but now we have to pay attention to is it solid or dashed in the shading. Okay, so again, it's a negative b over 2a, and we're going to plug it in. Okay, so there's my a, there's my b. Well, my b is negative, and we're plugging it into a negative, so it's going to make it a positive 2. And then 2 times a negative 1 is going to make it a negative 2. Okay, well that simplifies down to a negative 1. Okay, we like that one better than the 1, 6. Okay, now wherever there's an x, you're going to draw a parentheses and replace it. So there's an x, I'm going to replace it. There's an x, I'm going to replace it. Okay, order of operations, I'm going to do the exponents first. So a negative 1 times a negative 1 is a positive 1, but then I'm going to change it back to a negative. A negative times a negative is going to make it a positive 2. Okay, so left to right, this gives me a positive 1, and 1 plus 3 is, okay, so there's my vertex. Okay, so I'm going over 1, okay, but then I'm going to go up 1, 2, 3, 4, okay. So there's my vertex. Is it up or down? Okay, so it's down, okay, and the inequality that is here doesn't have the bar below it, so it means it's going to be a dashed line, okay, that's going through here. And then the part that faces the y, so I'm talking about the inequality, this part right here, okay, the part that faces the y is the bigger part of the sign. And y's get bigger as they go this way, okay, so that means that the shading is going to be on the outside of this parabola, okay. If it was y is smaller, which it's not, the y's get smaller going this way, so then it would be on the inside of the parabola, okay. So this is what it's like. So that one was 3 points. So is it in the right spot? Is it dashed? And then is it shaded properly? Oh my goodness, finally done, guys. And it is 5:21. I'm gonna go home and take a nap. See you for class.